Hello, today we're going to learn how to name and draw structural formulas for hydrocarbons. Objectives for this video. In this video you will be able to identify hydrocarbon molecules by the number of carbon atoms. Also, you will be able to write the UPAC names and draw the structural formulas for alkanes, alkenes, alkynes, and aromatics. The International Union of Pure and Applied Chemistry is a worldwide scientific organization that objectively addresses global issues in the chemical sciences. UPAC serves the international community in the dual function of a basic science and a mission-oriented union. For more than 80 years, UPAC has fostered worldwide communications in the chemical sciences, uniting the academic, industrial, and public sectors of chemistry in a common language. The union is recognized as the world authority on chemical nomenclature, terminology, standardized measurement methods, and critically evaluated chemical data. The UPAC system is used by chemists to name organic compounds, and hydrocarbons is an organic compound. And there are many hydrocarbons, and we need to identify each one. For this reason, it's important to have defined rules to name them. A common hydrocarbon is the methane. Methane is a fall in electrical generation, and it produces less amount of carbon dioxide. The propane is another example of a common hydrocarbon, and it is generally used for heating and cooking. The butane is another example, and it is generally used in lighters and in aerosol cans. There are alkanes. In the hydrocarbon family, there are alkenes, alkynes, and aromatics. An alkene has only single bonds. An alkene contains one or more double bonds between carbon atoms. An alkyne contains a triple bond. And the aromatics compound contains benzene. That is a molecule that has a ring of six carbon atoms with one hydrogen atom attached to each carbon. The alkanes are a class of hydrocarbons in which the atoms are connected by single bonds, and one of the most common uses of alkanes is as fuels. As we can see, all the names for alkanes end in ane. Alkenes with 5 or more carbon atoms in a chain are named using Greek prefixes pen, ex, ep, oct, non, and so on. Steps to name alkanes. First, we need to count the number of carbon atoms in the longest continuous chain. And then we need to number each carbon in the parent chain. And then we need to name each alkyl group substitute. This is a continuous chain, and this is a branched alkane. A branched alkane has alkyl groups. An alkyl group is a carbon branch that is attached to a carbon chain. To name, the alkyl group is named by replacing the ane ending of the corresponding alkane name with -il. Alkyl groups cannot exist on their own. They must be attached to a carbon chain. If the same alkyl group occurs more than once as a branch on the parent structure, we need to use a prefix like D, 3, tetra, and so on before its name to indicate how many times it appears. When different alkyl groups are attached to the same parent structure, we need to place their names in alphabetical order. And then we need to write their name using hyphens to separate numbers from words and commas to separate numbers. Now write the UPAC name for a hydrocarbon. Now we will show you an example of how to write the UPAC name for a hydrocarbon. Let's start. Well, this is a hydrocarbon and we need to write the UPAC name for this hydrocarbon. So first we need to find the largest chain. This is a chain and this is a chain. This chain has 1, 2, 3, 4, 5, 6, 7, 8 carbons. And this chain has 1, 2, 3, 4, 5, 7, 8, 9 carbons. So this is the largest chain. And then we need to number the carbon atoms starting from the end that are a substituent. From this part of the hydrocarbon, the letter substituent is in the 1, 2, 3, 4 position. But if we start from this part of the chain, the first substituent is in the 1, 2, in the third position. So we will start for this part from this part of the chain. This will be the carbon number 1, the carbon number 2, the carbon number 3, the carbon number 4, 5, 6, 7, 8, and 9. And now we need to name each substituent. This is a methyl because it has only one carbon. Methyl. And this is a methyl also. And also it is a methyl. But is this a propyl or a ethyl or an ethyl? No, this is an isopropyl. And for name this hydrocarbon, we need to start for the alkyl group that in alphabetical order. And this is first because it starts with I. So the isopropyl is in the fourth position. So we need to start for fourth position. And if the same alkyl groups occurs more than once, a branch on the parent structure, we need to use a prefix D, 3, tetra, and so on. But first we need to mention the positions of the alkyl groups. This methyl is in the third position. This is in the 5th position, is in the 5th position, and this is in the 6th position. And we have 1, 2, 3. 3 methyl. And now, how many carbons we have in our largest chain? We have 9. So we need to mention the number of carbons in our largest chain. None, because the prefix is none for 9. None, and this is an alkene because it has only single bonds. We need to end this name with this prefix. And now we have the UPAC name for this hydrocarbon. If we have the name, we want to draw the skeletal formula for the hydrocarbon. First, we need to draw the main chain of carbon atoms, and then we need to number the chain and place the substituent on the carbons indicated by the numbers. And finally, we need to add the correct number of hydrogen atoms to give 4 bonds to each carbon atom. We have the name, the UPAC name for the hydrocarbon, and we want to draw the skeletal formula. Now we need to draw the structural formula for this hydrocarbon. This part of the name tells us the classification, and this means that in our hydrocarbons we only have single bonds, and in our largest chain of our hydrocarbon we have 5 carbons, and we only have methyls, and we have 3 methyls in this position, in 2 positions of our largest chain. In the second position we also have a methyl, and in the 4th position. So we will start for our largest chain, and in our largest chain we have 5 carbons. 1 carbon, 2 carbons, 3 carbons, 4 carbons, 5 carbons. And we will start from this part of the chain. So this can be the carbon 1, carbon 2, 3, 4, and 5. And in the second position we have a methyl. This is a methyl. And in the second position we also have another methyl. And in the 4th position we have another methyl. So we have 1, 2, 3 methyls. 3 methyls. And now we have to add the correct number of hydrogen atoms to give 4 bonds to each carbon atom. So in this position we have only 1 bond, so we have 4. And these will be 3 hydrogens. And in this position we have 1, 2, 3, 4 bonds, so we don't need another hydrogen. But in this position we have 1, 2 bonds, so we need another 2 hydrogens, another 2 bonds, so we need to write 2 hydrogens. And in this position we have 1, 2, 3 bonds, and we need to have 4 bonds, so we need to draw another hydrogen. And now we have 1, 2, 3, 4 bonds. And in this position we have only 1 bond, so we need to have 4 and 3 hydrogens, and we need 3 hydrogens. This is the structural formula for this hydrogen.
Hi, I'm going to explain how to name alkenes. The first step is find the longest chain. The parent chains must include double bond. You can indicate with a number the location of each bond. 1, 2, 3 at the end. Next, you will name the outside carbons with the prefix methyl, Finally, you will locate first where methyl are located, in which number. We have 2 methyl, you write 2, then 4 because it's located in 4, then 7, 3 methyl because are 3, then you will indicate the number of where are located double bonds, right here and here. This bond is located in number 2, you write 2 and 4 and write prefix octa because the long chain have 8 carbons. Dn because are 2 bonds in the longest chain. Dn, and finally change the ending n to in.
Hi everyone, I'm going to talk about alkynes. Alkynes are the carbons that have carbon-carbon triple bond functional groups. To name alkynes, the first step is to find the longest parent chain that must include the triple bond. In this case, is carbon because we have the triple bond. The second step is number the carbon from the ending closer to the triple bond. We have the numbers the next step is to name these carbons. These 2 carbons are methyl and these are we have to indicate with a number the location of the triple bond is 4, and the number we must put will be the shortest to the triple bond. We have here the number, and then we have to put for alphabetical order the carbons. Here DE are first at DM, so the EF are going to be first with the number of location of the carbon, that is 6 ethyl. Then the location of the others 2, 3 dimethyl because are 2 methyls, and then we have to put the shortest number with the triple bond, that is 4, and then we have to change the ending n to in for the triple bond, that is octane because have 8 carbons.
Hydrocarbon derivatives. Organic compounds are divided into two main classes, hydrocarbons and hydrocarbon derivatives. Hydrocarbon derivatives are molecular compounds of carbon and at least one other element that is not hydrogen.